Hello everyone. Thank you for joining this webinar. I'm Francis, and me and Jonathan, who will present over this, will talk about this topic of the transformation, AI-powered audits, and the future to full agentic auditor. For my part, it's mostly about how we started implementing this by solving a problem we had and creating a tool to explore the idea of automating 80% of audits and building towards full autonomy. As part of our work, we did audits on website. And this was mostly done manually, like the data gathering for performance, accessibility, and all these other categories. The code base analysis, and just manual checks on the website. We did use some services and a static code analysis tool, but it can be very tedious to do. And the most important part is the report writing, where we write our insights based on the data that we have gathered into these two documents, the executive summary and the detailed report that we can see on the right. A lot of this was repetitive work, and only a small slice of that was actual analysis. So the cost was time inconsistency, and ultimately it just leads to burning out. Automation solves this kind of problem, so we built for that. And the reason why we built this is to free the auditors from repetitive work and just let automation handle 80% so auditors can focus on the 20% that matters. And lastly, to understand the AI landscape better and integrate it in our workflow. So how the tool currently works is as follows. So you have the tool here and some diagram. So the auditor provides the URL and other optional parameters like the reviewer, the website URL, the other paths to the website, and the absolute path to the code base in the file system. So this is mainly used internally, and then we can start the analysis. It runs both analysis of site and the code base. So for the site analysis, for each URL, it runs the data collectors like PageSpeed Insights, Wave, and so on. It then formats and aggregate raw data that we can see here to be passed to the AI for analysis to generate the executive summary and the detailed report. We also use structured output, as we can see here, where we define a schema of the object shape that we expect the LLM to respond with. So this reduces a lot of hallucinations and it consistently responds with the object shape that we have defined. And at the same time, we also do the code-based analysis where we find important files, we parse and chunk each file, and then pass them to the AI to generate file-level summaries. We again use structured output here for consistency. We then generate the directory tree so that the LLM can have, or the AI can have, a high-level overview of the codebase. We then pass both data points to the AI to create a final report of the codebase. We assemble the final report. We create and populate a Google Doc for the detailed report and store the report for history. We then display the results to the UI, as we can see here. So we have this dashboard that contains all the data that we have gathered and the generated content that the AI has generated. So we can look into the executive report, as we can see here, and the insights in the Google Doc. As we can see here. So all of this was generated by AI, and the scan results is basically there for the auditor to have some kind of check. Since the LM can hallucinate, this is here for verification. We can also look into the reports that contains the previous audits, and potentially in the future we can use this as context to the LLM to create a more effective reports. And that is how the tool works. So what are the ups and downs? Like, what worked well is that we have automated 80% of the manual steps. We have used AI to generate all of the reports. So we can now iterate faster. There's consistent structure, and we can just create a lot of reports. And of course, there are things that we are not satisfied with, like edge cases still need oversight because nuance is hard, and that is to be expected. That's why we still have humans in the loop for this kind of edge cases for them to amend. And also another problem is that context window. We currently use Gemini, which has a lot of context window. I believe 1 million of them. But more on this later. This will be discussed by Jonathan. So what's the next step? The next step is to build this agentic AI, because what we currently have is smart, but it is not agentic. It doesn't know how to plan, doesn't perceive context. Right? So agentic AI is basically an AI that perceives context, makes a plan, and takes actions to achieve user goals. We are currently implementing this in part of our tool, which is the code-based analysis part. And if it works well, we are going to increase the scope. So in order to do that, we need the AI to be capable of understanding the code base. And I guess the first step is for it to be able to read a file. And we are using this kind of protocol called MCP, Model Context Protocol. It is a standardized open protocol that enables AI applications to seamlessly connect with external data sources and tools. It basically wraps around the future of an LLM to be able to call functions like code execution. You can, of course, handle this kind of thing, but having this kind of standard helps speed up integration, and you don't need to create your own bespoke implementations that you need to maintain. And the code below is taken from the official repository from MCP. And the one on the left is the tool metadata. We have the name of the tool, the description, and the input schema, which is just the JSON schema for the arguments to be passed to the tool. We define a list of tool metadata that serves as a contract with LLM for it to understand what tools it can call and what arguments to pass to specific tools. And the one on the right is the implementation of the tool, where we do validation, and ultimately we just return the content of the file. So with that said, that enables AI to have some capability of reading from a file. And there's the first step to this code-based analysis tool that we are implementing with agentic AI. So how does this all work? In order for an agentic AI to work, we first need to have an objective. For example, we analyze the code base at this particular path. We then put this objective into a context, the state for the run. The context contains objective is what we want, and the history, what we've seen so far, which is just the memory for the LLM. This context is then passed to the planner to create a plan based on what it assessed on the context. So what's the next step? So it reads the objective, it reads into the history, and creates a plan based on that. So the planner can output the following object. So a plan, so we have the type, the tool, the arguments to pass to the tool, and its reasoning. The reasoning model of GPT are especially very good with this. We then pass the plan to the executor that runs the chosen tool and creates an observation. And the plan in this case is list files. So it calls the list files tools with this particular argument, the path to the code base, because its reasoning might be that it read the objective to analyze the code base, but it did not see anything in the history. So the logical step is to list the files. The executor can output the following: an observation that contains the analysis, the tool, and the arguments. The analysis is just a union of different analysis. In our case, the list file for the list files tool, we have the list files analysis that contains the summary and the files. The summary is just a human readable summary of the files, and the files is just the paths discovered that is taken from the MCP server. We then put this observation into the context history to remember what happened. And after one loop, the history has at least one observation. And this is just done continuously in a loop. So we keep iterating, we plan, execute, and remember. So the planner now has this new context that contains an observation. So it probably created a plan of this read file tool, of calling this read file tool at this particular path. So the readme.md, because its reasoning might be the readme might contain a lot of information about the code base, so that's the logical step to make. We just push the observation into the context history, and so the history grows, and more context means better next plans. We then continue this kind of workflow until the planner has assessed that objective has been completed, to which the type is now finished. We can then just break out of the loop and do something with a final context that might contain a lot of observations. And that is how agentic AI works on a high-level overview. You can do a lot more things to this. For example, you can replace the history with a library for memory. There's a lot of libraries out there. And also leverage vector embeddings just to make the LLM more effective. You can also possibly make the planner multi-step. Instead of a single plan, it lays out multiple plans. And just a lot more things to make this more robust, more effective. And this kind of workflow kind of mimics us humans of having an objective, a goal, creating a plan, executing the plan, creating our own observations, and keeping things into mind, like remembering them, where we just do that on and on until we have completed the objective. And that is how this agentic AI works. And that is everything from me. And the next presenter will be Jonathan, who will talk about the topic more in detail, more about LLM in general. And thank you for listening. That's all.
Hello everyone, I'm Jonathan. Today I will be talking about a topic on how we are currently utilizing generative AI in our workflow as web auditors. So as the title says, the transformation, AI-powered audits and the future to full agentic auditor. So we'll walk through starting with the manual audit challenges we've encountered and how the flow transformed using our internal tool to automate parts of the process. We'll also look at the benefits and challenges we have observed in integrating AI in our tool, as well as the future roadmap to improve its capability. Let's revisit the manual workflow that was discussed in the previous episode. It starts with running a scanner tool. So we utilize proven effective tools like PageSpeed Insights for web vitals, Lighthouse for page load performance, ActionWave for accessibility, MDN Observatory and ZAP for security vulnerabilities, and some code-based analysis tools like NIP, MAJ, and JSCPD. These tools are great at identifying potential issues, but they generate raw data in different formats. This led us to the next step, which is data gathering. From our experience, we would go through the results from each tool, manually taking screenshots, making notes, and extracting key findings. Following that would be data documentation. This involved manually collating all the gathered data in a document file. We would spend considerable effort copy-pasting findings, screenshots, and even templated sections into a single cohesive document file. This is to ensure that proper formatting and structure is being applied. And finally, the data analysis phase. Here, we would go through into the collated scan results, manually interpret the findings, identifying root causes, and formulating the appropriate recommendations. We repeat these steps for each tool, which is tedious and wastes large amount of time. Let's see how the audit tool helps in reducing the amount of time creating a draft report. As shown in Francis' demo earlier, the audit tool app runs several tools in parallel, collecting raw data from different tools, presenting this data in the app itself, cleaning the data, and then feeding it to the AI. Then AI's output will then be imported to the document file. All of these processes happen in the audit tool app. As auditors, we just input our name, the main or origin URL we want to scan, some additional URLs if there's any, then initiate the scan. After just few minutes, you will have the draft report available in Google Docs. In a way, we were able to combine all the manual processes in the audit tool app. Also, AI's output already includes tabulated metrics data, together with the analysis, impacts, and some technical recommendations. But do note that this is just a draft version of the report. Auditors need to remain in the loop, like reading and confirming the generated content, adding contents that were not part of the automated scan tools, and making sure that AI's output is relevant. Also, in the demo earlier, Francis showed the architecture diagram and how the audit tool works. Now, let's focus on the role of generative AI in our audit tool. Scanner tools were automated to gather data, which reduces a large amount of time as compared to running standalone tool one by one. And from this collected data, generative AI can create content from it. So what is generative AI? It is a type of artificial intelligence that can create new content like text, code, image, audio, and even video. Most of the generative AI tools today comes in a chat-like application, like OpenAI's ChatGPT, Google's Gemini, Anthropic's Claude, and others. We interact with it by providing instructions, context, and it will generate new content for us. In our current use case, we're leveraging generative AI's augmentation capabilities, where we feed it data collected from different tools and prompt the AI model to generate a draft report analysis for us. It is not a full automation since auditors still remain in the loop. There are several challenges we encountered when we were developing the audit tool. We needed a model that supports a structured output to generate the executive report we needed. But this parameter support is mostly available to paid AI models. Another thing to consider is the token limitations. Since we are sending lots of data from different tools, we need a model that can handle large amount of input tokens. And more importantly, we also need a model that can output large amount of tokens. This is to ensure that the generated content is not being cut off due to the output limitations. Here are some of the models we tried from the Open Router LLM marketplace. We have the Meta Llama 3.1, which supports around 66,000 tokens, but this is shared, meaning if you have an input context of 50,000, the output will be maxed out at approximately 16,000 tokens. This is the same for Mistral Small, which has limit of 96,000 tokens, and DeepSeek R1, which has around 164,000 tokens. We also explored Google's Gemini 2.5, which has dedicated input context limit of around 1M or 1 million, and a max output token of 66,000. But it has a limitation since we're only using the free tier. So at maximum, Gemini model can only process around 250,000 tokens in a minute, which is still more than enough as compared to DeepSeek R1's limitations. So currently, we are using Gemini 2.5 flashlight model to generate a draft report analysis. So to utilize an AI model, we need to have effective prompting. For the prompt, we have the following system and user prompts. For the system prompt, we enumerate the following contexts. First is the format that it will output. We set it to be a strictly markdown string. Second is the model persona. We set it to be an expert web developer consultant. Third is the content requirements of each tool, followed by the analysis and formatting requirements. As for the user prompt, we have it set to analyze the provided data, appending the actual data needed for the analysis. Here's an example of system prompt we are using. We have the output format, labeled as 1, model persona in 2, section content, which is labeled in 3, analysis requirements and formatting requirements in 4 and 5. Now, let's take a look at some portion of the draft generated by the AI model. Here, we have the largest contentful paint, or LCP result and analysis. It briefly explains what is LCP, tabulates the data, describes and enumerates found issues, and provides technical recommendations to improve such metrics. Here's another section, brief explanation regarding security, enumerating the test results, which are passing and failing, and provides technical recommendations to fix the issue, as well as some business and user impact. Now, let's take a look at the impacts it creates in our audit service. Here we have the advantages, which are enhanced output, meaning AI helps us generate comprehensive, technical, and highly structured drafts. Another advantage is time or resource savings. With the help of audit tool, we can get or create a comprehensive draft analysis in just a few minutes. This frees up substantial auditor time and resources for more complex tasks. We can also consider scalability here as an advantage, since we can create multiple draft reports in a small time window. And lastly, would be higher quality insights, since AI can provide granular and detailed analysis, and you can also customize your prompt. However, like many or any powerful new technology, integrating generative AI also comes with its own set of challenges. And we are currently actively managing it and addressing it. So one of them is AI hallucinations, where AI outputs incorrect or inaccurate contents. We can mitigate this problem by human oversight and final review by the auditors, as well as making an effective prompt engineering. Another challenge is the continuous technology evolution. As developers, we need to be up to date with the technology we are using. Last would be the cost optimization. While we are currently utilizing free tier and seeing an effective or added value in our service, later we may need to subscribe to a higher tier and explore to optimize token usage and prompts for efficiency. Currently, we are still in MVP or minimum viable phase. We are actively looking for features and improvements of the audit application. Here are some of the things that we're currently working on. Competitor comparison, where we will have additional URL specifically for competitors. We will compare some of the key metrics like core web vitals for both the client and competitor site. Currently, we are dumping generated report drafts in Google Docs. We are considering using what you see is what you get editor inside the app. In this way, we won't need to use a separate app and would be easier to navigate between the raw data and the generated analysis. We're also looking for improvements to make the report elegant and not only contains pure text. So we're considering a feature like smart screenshots to help insert relevant or important images in the draft report. As of the moment, we are generating the content in a one-shot prompt, meaning we send the entire collection of data and let AI analyze it all. We are considering to make this more targeted or modular. This may come useful when a client only wants to audit a specific health check of their website, like performance focus audit or SEO focus audit, or even security focus audit. Aside from the app features, we're also exploring its capability to be part of the client's continuous integration, continuous delivery pipeline, or CI/CD. For the production, we can run both the lab and field data tools like Lighthouse, Core Web Vitals, ZAP, and Observatory. And for the testing environments, we can run only the lab data tools like Lighthouse, Axe, and Wave. Another important thing is dealing with its extensibility. We're looking to improve the tool in such a way that it would be easy to integrate other data sources or tools, like integrating version lens from VS Code extensions to detect outdated packages from the code base, and even other metric tools like Yellow Lab tools. And maybe one last thing, we're also researching and experimenting if it's possible to turn this tool to a full agentic AI application, meaning it will not be just a limited to running tools and creating draft reports, but will also actively participate in how to resolve the issues in its entire life cycle. It would also be more goal oriented and responsible in breaking down goals to subtasks. Better tool orchestration, meaning it will not just run the tools based on the script, but would be dynamic depending on the needs. It would also have better understanding of the context depending on its learning outcomes and collected data. And maybe even monitoring can also be part of its capability. So, as a conclusion, AI augmentation enhances human expertise, driving unparalleled efficiency and strategic advantages in our audit process. AI helps us with the data processing and analysis, resulting to a fast generation of draft reports and iteration, saving us time and able to focus on our other complex tasks. We are continuously looking for improvements and features, from application improvements to potential agentic tool. It helps us simplify and elevate our workflow as web auditors. That's all for this episode. Thank you for attending. And if you have any questions, please feel free to drop them in the Zoom chat and we'll get back to you as soon as possible. Thank you again and have a nice day.